I'm Oliver Gao. I'm the director of Cornell System Engineering Program. Today, I'm very delighted to have Alice Squires, who is a clinical associate professor with the Washington State University. And actually, she got her undergrad degree from the University of Maryland and MBA from George Mason University. And then, after she has had so many different diversified experience with so many big companies, and she decided to go back for a PhD. So she did her PhD with the systems engineering, which exactly my program is about. She did her PhD in system engineering from Stevens Institute of Technology, which is another, I think, big name in system engineering education. So welcome, Alice. So I know, I was looking at your bio, your professional background. I was so impressed. You have, this working experience with all these big names of these industry companies. That definitely shows that you are truly a systems person. I think I'll stop here, and I would like to invite you to tell us more about yourself, your career, or whatever you want to tell us to get us started with this systems conversation.
Okay, sure. What I'll tell you is, after I got my electrical engineering degree and went into industry as an electrical engineer, working in hardware design, I just loved it, but quickly we went from very small designs on very large scale integrated circuits to larger and larger designs, to the point where I felt like we were designing an entire system on a chip.
Mm-hmm.
And we had to really think more systemically in order to do that. As logic designers, we now were becoming systems designers.
Mm-hmm.
But I didn't realize it at the time. As a matter of fact, I'd never even heard of systems engineering. And then, of course, moving through the field, going into higher level positions, taking technical leadership roles, I eventually started to want to learn more about the business, which is what led me to getting my MBA. And then coming back into industry again, I began to get exposed to this field called systems engineering, and got a little curious. What is that all about?
Mm-hmm.
And interestingly, when I decided to go back for my doctorate in systems engineering, I realized, hey, I've been doing this for like a decade or two and didn't even realize it was systems engineering. And so I think that's probably true for a lot of people, especially as they get later in their career. You have to think about more systemically about interfacing across the disciplines, about the requirements. You have to think about the system life cycle. And so really you're doing a lot of activity that's considered systems engineering process, and you may or may not realize it. You may be an electrical engineer, a mechanical engineer, an aerospace engineer, although aerospace engineers are typically exposed to systems engineering a little earlier in the cycle, because systems engineering has sort of come up through the aerospace and defense disciplines. But so I think I've sort of gotten on a couple different threads where, one, I'd like to expose all engineers to systems-based education, because I think today it's required to do your job, to understand your place in the system.
That's true.
Where you fit in the larger system. But I've also focused consistently in my academia portion of my career in systems engineering education, actually. So it's interesting that you talk about Stevens sort of being a front runner in systems engineering education. When I was there, we started off as a department, and I was working there while getting my doctorate. And by the time I graduated, we were the School of Systems and Enterprises.
Yes, yeah, that's true. So I think when you were talking about your experience, and also talking about how you moved from engineer and then MBA and then go to system engineer, all these things. So of course I believe there has got to be something that is driving you behind for you to pursue this. And I can see that you're thinking about dealing with huge complex challenges of that our society is facing today. So in your eyes, what do you view as some key examples of the system challenges that the society is facing, and what do you see the value of systems engineering in dealing with, in coping with those challenges that you're concerned about?
Absolutely. So the challenges today are primarily driven by the types of systems that we are being required, maybe not required is not the right word, driven to develop. They're changing so much from the original type of systems that we were working on. Well, we've had some very complex, challenging systems in the space program, aerospace program, but now all of a sudden, all of the systems, we've got cyber physical systems, we've got autonomous systems, we've got smart cities. All of a sudden we're realizing that systems solutions are really what are being required to meet human needs around the world.
Mm-hmm.
And so by definition, because we're trying to meet these human needs in a more broad sense, and we're becoming a global society, the result is the requirement for these huge complex systems.
Mm-hmm. Yeah, I think that's true. So definitely, given all these challenge, right? So while a lot of time we were talking about system engineering, and of course, as researchers or as scholars in this area, I believe people are also trying hard to define this discipline, right? I think when we talk about system engineering, a lot of time we also talk about system science. And I can see that actually you are really an ideal person who actually connects system science and system engineering. So what's in your view, what's in your view system science, and what is in your view system engineering, and what is the difference and what is the connection?
Well, okay, so system science is the study of the nature of systems, so systems behavior. There's some interesting challenges in system science as far as how do you describe complexity, how do you deal with emergence, how do you deal with these sort of more advanced concepts of systems. And it's so important to me, especially coming from industry, that we move beyond this idea of defining ourselves. Mm-hmm. We're sort of in the systems engineering community, we're still seemingly, there's a lot of focus on this idea of what is systems engineering? How do we define systems engineering? We're still working on that, which is just a sort of a marker to me, an indication of, that we haven't moved beyond that to just doing the systems engineering. Mm-hmm. So I kind of like the doing part of the systems engineering. So where do I see the connection? Well, to me, it's like, why are we asking what the connection is? There's clearly systems science supports systems engineering, just like all sciences support the associated engineering. Do you see what I'm saying?
Yes.
So we haven't gone past the question phase because we're still building the systems science foundation, and we're still adjusting systems engineering. Why is it so hard? Because the systems keep changing that we're working on, and so that's sort of creating this environment where we're asking these types of questions.
Yes, I totally agree with you. Actually, when I was at an INCOSE meeting, which you can see that was heavily participated by people from industry, while we don't see kind of very much participation from the academics. So, and also I was looking at that, I had a feeling, I feel like, this, a lot of times I think practice is ahead of scientific research, and practice actually brings in the problems, and then that motivates the development of scientific disciplinary. I'm also feeling I feel system engineering seems to be now ahead of the development of system science, actually put a lot of pressure and a demand for academics to catch up.
Absolutely. As a matter of fact, today in my talk, what I'm going to show you is that connection between the talk is actually broken up. It calls practice is the actual deployment of the system into the field. The engineering itself is the design of the system, and then the science is clearly the evidence and support for the probable systems, and then the philosophy of systems, and then how that relates to society. And what I'm going to show you is we're sort of taking this backward path around. And the person who presented this was this architecture of systemology that I'm going to show you today was Dr. David Rousseau at Nkosi this summer. And it's sort of a follow-on to the systems praxis framework, which I'll also show you today, which was intended for systems practice to clear up terminology between the theory and philosophy and the actual practice of systems engineering. And so again, there's this struggle with how do we put all this into a framework, but what's happening is, yes, we're coming from the other direction around the spiral from the actual practice to the philosophy. Like you say, the practice is driving the development of the principles more so than the philosophy. And so does that mean systems engineering is or is not a discipline? Well, no, it just means that the reason we're asking that question is because we're just going around it the opposite direction, where a lot of times you're going around from philosophy to science to engineering to practice, in other fields, and so you don't ask that question.
Yeah, I totally agree with you. And also I think that nowadays with all this development, and even earlier you mentioned kind of this autonomous driven vehicles, all this artificial intelligence, and if you look at the frontier, and you can see that actually a lot of industry, like kind of Google driverless cars, actually a lot of industry, they are leading the frontier, while they're even hiring people from academics into their labs.
Yes.
So I think it's really true. I think at some point it's probably sometimes the scientific research is leading. Sometimes the practice is kind of this spiral evolution of scientific research. Now probably I was really impressed. You can see that you studied as an engineering background and you did an MBA and you did a lot of work, and then you went to system engineering, and I can see that you do a lot of technical management and even leadership. So now, why system engineering and leadership? What is how have you found, for example, after you got your PhD in system engineering, how did you practice? How did it help you in kind of giving you more advantage in in overall leadership, not only technical leadership? Because I see that you do a lot of management and leadership, and also you do system thinking. So how do all these system engineers help you in your leadership management?
Well, first of all, systems engineers have to be leaders. They cannot be effective if they're not leaders.
Can I insert? Or can we say in another way, we have to make leaders to at least have systems knowledge.
Yes, so systems engineers have to be leaders, and leaders, well, if you ask me, and I might be biased on this, it doesn't hurt for citizens to have systems knowledge. It can absolutely essential for leadership to be effective, and for systems engineers to be effective, but also helpful in just your daily life if you can think more systemically. Think of, instead of fixating on events, think about the events and the patterns that lead to the events and the system that drives the patterns that lead to the events. And so the idea of systems and understanding systems, I think, is currently today undervalued, but there's this huge demand for this understanding of systems because of the complexity of the systems that every single person is having to deal with.
Yeah, that's so amazing. And speaking of leadership, technical management, of course, there is a lot of discussion about gender difference, men versus women. NPR, a lot of reports that are talking about the gender difference and even gender bias. Even something in our engineering education, like if you look at the statistics of the engineering colleges or engineering departments, usually we have less women in the STEM disciplines, right? So, but the thing I noticed, actually, I want to let you know two statistics actually. For the Cornell system engineering, our recruitment, our master student, actually we have 30% women students. So this is for our MH program. And actually this year, this just the incoming student, this fall, incoming to the College of Engineering here at Cornell, we have half women students. But and I noticed that you are working on I think this autobiography, probably your career or with this IEEE women engineering. So and now being a women engineering leader. So I would also like to hear your view about how what is the current status of women in leadership and management, and how can we, either as educators or as advocates, how can we improve the situation, and what shall we do?
Okay, and so just a little bit about my autobiography. It's sort of, insightful. I think reflection is always insightful. And so in order to write the autobiography, I've had to be a bit more reflective lately about my career. And it's interesting to me that early on in my career, there were, bits and pieces where perhaps there were challenges and obstacles for me because I was a woman. But either I was more oblivious to it, or it just, compared to all of my opportunities and abilities, and it didn't seem to have much of an effect. But as I get later in my career, it's actually become more of an issue. I don't know if it's because I'm becoming more aware, but I think there's a certain expectation for women that they've done the work, that they've gotten the education, same as the men have, and then they're in a certain situation and they're being treated differently. When they've reached a point where, they don't need to be the one taking the meeting minutes or putting up the post-it notes. It needs to be, or doing the administrative tasks in the room. It needs to be a shared responsibility when the room is full of leaders. It's not just the women that should be doing the, like I say, administrative duties. So I've noticed it actually to be more of an issue later on, and it's brought me to become more of an advocate for women. And so now I'm getting more insight into how it is today for younger women, because there's a whole group of people, men and women, who would like to see women not have challenges and obstacles just because of their gender. Everybody has challenges and obstacles, but they'd like it to be not related to the fact of whether they're a man or a woman. And so men and women are working together on this. In my generation, I'll say, for the younger generations, and what we see is, when you look more broadly, it's not just women. It's any kind of a context where you're the only one. It doesn't matter if you're the only man in an all women's field, or when you're the only one, you face these obstacles, these biases, and so it's difficult. And so what do we have to do? We have to raise awareness of how our actions are interpreted by the recipient of our behavior, and also whether we're being whether we have these an unconscious bias in the way we're behaving, but creating an open environment where everyone feels welcome. I think if you can just focus on more the positives, not on the negatives, but more on the positives. How do we create an open, welcoming environment? How do we ensure that we're being as equitable as possible? How do we attract the best and the brightest and the most qualified, factoring in, the fact that self-efficacy may be more of a challenge for women than men. Mm-hmm. So if we describe an opportunity in a way that a woman doesn't feel that she can meet 100%, she might not pursue that opportunity where a man might. And so being aware of that, looking at the research, being aware of these challenges, and then revamping the actual description of the opportunity, right? Mm-hmm. So that it's more welcoming to anyone. Does that help?
Yes, absolutely.
So focusing, I would like to just urge that it's men and women collaborating on this issue, and it is an issue. I get a lot of kickback sometimes that it's either not an issue, or women maybe leave engineering because they decide to raise a family, and I think it's just a cultural belief. Mm-hmm. I'd like to work more on the research, but currently the research says no, that's not it. That's only accounts for a small percentage. Why are women leaving engineering? Let's find out why, and let's address it. But let's address it for men and women, right? Mm-hmm. Let's just make the environment more welcoming for all. Let's sort of take a broader perspective. I'd like to be at a point where we're not having this conversation, right?
Yes,
I mean, that would be the vision.
That's right. We don't have to make it, a conversation. It's kind of just things that happen naturally.
Yes.
Right. So,
absolutely.
Speaking of that, it's kind of, again, I'm an engineer, following my kind of engineer thinking kind of habit. So, especially in a system engineer, like kind of the society, even for, of course, kind of the society, even human history, we studied actually, women were the leaders, right? Women were the leader. Women made all those decisions, right? And later on, all these things evolve. Of course, one of the key concepts in system engineering is that, we want to optimize the system so that who is best at doing what can be assigned or can be naturally assigned to doing what. So of course, I think you are saying that you are still doing some research to find out why something happened the way it happened. So I think, in my mind, like in my life, with kind of my mom and my wife and my daughter, so I feel actually, personally, I feel like women have very good talents in leadership. It's probably just kind of, the style of leadership between men and women is different.
Yes.
Kind of the style that men just present makes people feel, this is quote unquote leadership. While the approach that the women take to get things done, you are like more in general milder and a little bit more reserved than men. Mm-hmm. But in the end, actually, women probably could get a lot of leadership things done in the smoother way.
More, the research says that there's a more collaborative atmosphere.
Yes, yeah. So that's why I'm thinking kind of, even, I guess there might be some kind of misconception
of what leadership is.
Yes, that's right.
That might be. So that might be something we could think about tackling. I'd like to work on aspects like that, where we sort of take gender out of the equation and fix sort of the root problem. Uh-huh. So yes, it could be a misconception of what leadership is.
Yeah, that's right. In kind of leadership happens at so many different levels, at so many different units. Kind of taking as an example, a very fundamental unit of society, household, right? I don't know, like if you do of course, probably 50 years ago versus now, if you do a survey of just kind of on a daily basis for each household, how many decisions are made by women, how many are made by men, and I guess probably we might find out in a household probably at the least you could find out women probably make better decisions than men do.
Yeah, there is actually a group of research on decision making and how women make decisions versus how men make decisions. It's interesting what you say about the household, and then I can just think about my own, personal experience in my household. I have 3 sons and a husband, so we've got 4 men and 1 woman now. Not all my sons live at home, but right now actually 2 of them are living at home, and a third, our youngest, is still highly involved in. And yeah, when you think about who makes the decisions, that's a really interesting question. My husband and I are very collaborative. But if you ask me who cleans, that's a different answer. And that's what I'm talking about when I say this whole impression about who does the administrative work, who does the office housework, who does the housework at home. You know what I'm saying?
Yes.
I think we need to address that as well.
Yeah. I think that's definitely very important. So speak of that. So kind of, I think you mentioned that you got your PhD degree from Stevens. So I just want to let you know, actually at Cornell, at the time you did your PhD at Cornell, unfortunately we did not have a PhD program in systems at that time. Okay. However, about 5 years ago, we actually not more than 5 years ago, actually the program was developing in such a situation that we decided to build the research arm of systems here at Cornell. So actually at that time we started our ESRA system seminar series, which you will be talking today. And another thing is that about 4 years ago we submitted a proposal to the New York State Department of Education to start a PhD program. So one thing that actually is very interesting is that I want to share with you. When we submitted the proposal, we intentionally dropped the word engineering, so that our PhD is a PhD in systems. It's not just limited to engineering, because we realized, including a lot of challenges that you mentioned earlier, the challenge we're facing, it's not just the engineering approach, it's actually a lot of like social science, psychology, human behavior. So our proposal was approved 2 years ago. So last year, 2017, we had our first cohort of PhD in systems with 13 PhD students started.
Excellent.
In the PhD, and this year we have more students joining us. I just want to share with you that we also have, now we have a PhD in systems actually that's open to students with any background. They can come to this program in pursuit of whatever they interpret as systems science or systems engineering. So in addition to this PhD, we have been running this Master of Engineering program in systems. We felt that I think you said earlier, you said everybody needs to be equipped with systems tools and with system approach. I totally agree with you. But on the other hand, for the education, for the higher education, our program, we focus on graduate level education. So we have a Master of Engineering program and a PhD program, but we don't have an undergraduate for system, because we feel like people need to have a T-shaped, right? System, we talk about this T-shaped knowledge structure. And even for you, right, you have background, you have bachelor's in one, you said that electrical engineering, and then later on you build the bar, right, the horizontal bar, right? So,
absolutely.
So we're building this. So for this, from your experience, what would you advise to our students in this Master of Engineering and the PhD programs? From your point of view, what would you say to them? What do you see as very important things that they need to have them equipped from the systems program?
Great question. Now, I don't want to forget to thank you for inviting me here to the Ezra Roundtable, and I think this is a wonderful idea, and I hope you keep inviting people from around the world to come here and talk with you and to participate in your seminar.
By the way, and also, I will also appreciate if we're very lucky and happy to have you, but I will appreciate if you suggest other names.
Okay.
Because you are so well connected.
Okay.
Yes.
I will think of that. But what would I advise to your students is to tackle challenging, hard, complex problems.
Mm-hmm.
And then apply the learning of systems to those hard, complex problems, because then the systems approach really takes on meaning. You can really see the value of that approach. Mm-hmm. And that's why I picked world peace today, to talk about, not that I have a solution, but to talk about the value proposition of systems approaches in solving these large, complex, maybe even impossible, right, to solve problems. And that's what I would say to those students. Start there, and then I probably don't need to convince you of the importance of taking a systems approach, and you will see the value of what's there today, and you will see where you can build on it, where it needs to be built on in order to solve that large complex problem. You'll see, oh, this next step needs to be taken. And for example, one of the things we found in the research that I'll talk a little bit about today is the role of the human in these hard problems. Is we need to do significantly more research in the humans that are developing the systems and the humans that are using the systems that are deployed, and the role of the human in the system. There's just we need to focus there, and there's a couple other large areas of research that we found in doing several workshops and talking with people about the grand challenges. We focused on, in this particular case, on the National Academy of Engineering Grand Challenges.
That's
and we
right,
picked 4 of them, and there came out some common areas of research that are lacking, and I'd say look at those areas, because the hypothesis is those common areas of research that are lacking also apply to other complex problems. And if we looked at world peace, which I'm talking about today, you'd see, wow, yeah, those areas of research would also apply to, really, I call that an opportunity. World peace is as an opportunity. Systems engineering can be used to solve problems, but also to seek opportunities as well.
Thank you. I mean, this is really enlightening to me, because when you, I think the first sentence you answered my question, I think you said that you would encourage them to embrace the challenge and tackle those complex systems, problems. I think I totally agree with. I think that's really the key, because I was thinking, like, the general paradigm of engineering thinking. So, for example, if I'm trained in mechanical and aerospace engineering, and I'm working with a team, and with some problems, if there's a mechanical problem, I will solve this problem happily. And as soon as it's out of my scope, and I feel, oh, it's out of my scope, that should be Jerry's work, and then I will stop back. So I guess a lot of our traditionally trained engineers, they are thinking this way: I'm so good, I'm working so well in my discipline, but outside that, not my business, right? And similarly, Jerry will think about, I'm working on this thing, that's not my business. So as a result, you can see that our engineers today, they are educated, they are so able to deal with all those problems falling within their domain.
Right.
And out of that, I think they have a very philosophical excuse, which is disciplinary in boundary. It's outside of my boundary. So, however, as you mentioned earlier, the nature of our today's society, the challenges are really cross-disciplinary. So as a result, actually, no such discipline that are trained, one, with techniques and skills, two, really with a mission to deal with this kind of system problem. And I really, I think your words really kind of made me think this way. So it's really not only equipping the student with the tools, but really kind of instill into these system students that they have the mission, they have the responsibility to deal with all these kind of cross-boundary problems that all the traditional engineers are shy of.
Yes, exactly. So it's like, you can build the well and fill it up with water, but you can't make people come and drink it, right? So how do you bring them to this idea where they see the value of the systems and see the need for communicating and collaborating with the other disciplines, and also even finding out that there's other people working on the same problem. They're just using different terminology. They're they could be in a completely different field. And the way to do that is to get them focused on to me, the way to do that is to get them focused on a larger vision.
That's true. Yeah.
And then they come up with the solutions. Oh, we need to work with we need to work with those guys.
That's
to
true.
achieve this larger vision.
Mm-hmm. So in your in your work with especially in your either in the leadership role or different levels of leadership roles, so what do you see as some important tools or thinking process or approaches did you apply? Like you feel, so for example, maybe this is not right. What are your secret weapons to be an effective systems leader and manager?
Secret weapons to be an effective systems leader and manager. I guess in some ways it does come with time, but it comes with, it has to come with challenges. It has to come with going outside your comfort zone. It has to come with making mistakes and seeing the impact of those mistakes. And so if we can in education, I do this sometimes, to my students, setting up a scenario where human nature might take them down a path that's not going to be effective. Mm-hmm. So they can see the impact, without actually causing any harm in real life, see the impact of that mistake. It can bring them to a sort of an aha or eureka moment.
That's right.
To sort of learn from their mistakes. But I think that you need, we sometimes historically call in systems engineering, you need the scars. You need the scars to become a systems engineer, but really we've got to get to the point where we're educating and maturing systems engineering without having decades of experience in industry. And so we've got to build these experiences in these challenges. We've got to start making our problems undefined. What the problem is even undefined. Helping lead our students to defining the right problems. Stop giving them the problem. What is the problem? Having them learn how to define it. Maybe let them do it wrong. See they can work on an entire solution and come to the realization that they solved the wrong problem and their solution is unusable, in practice or in society. And then undefined what the data is that they need, undefined, the solution set, make it complex, undefined, drive them outside of their comfort zone, try to learn about typical mistakes that have happened in the past and replicate the scenarios, so that your students can go through and learn from those mistakes. I think that's what you have to do to help people become leaders in systems engineering. So they have to learn by, I don't want to say failure, but learn by these challenges, like just working hard, working toward a challenge. And then I really try to focus on realistic scenarios and solutions. Mm-hmm. so that because everyone I feel like wants to make a difference and bring value and contribute. Like some of the most amazing things are, students helping young children, maybe with prosthetics or designing individual systems or adaptive learning. When you see the impact you're having on just citizens out in the world and how you're improving their lives, making their lives better, I think that's also an important aspect.
That's great. So probably I think we're getting to the end. I do have one question.
Okay.
I really want to ask you. So looking at the career, right? You had a very successful career across different industry, disciplines, with different companies, and we before we start, you were talking about. So of course, when you get closer to retirement, actually you think ahead. Okay, what do I want to do? What do I want to do? And then of course, in the end, and you said you decided to go for a PhD, and then now you come back to this education, right? So because I think, especially in the sense you're a system engineer, I believe you must have been very careful and selective of where you put your effort. So now I want to ask you, so after the whole kind of first part of your life of successful industry experience, of course you can do a lot of other things, but why education?
Wow, that's really an interesting question. I think that I've always had this desire from a very young age. This might sound a little philosophical, but to bring joy and happiness to the world. And it sort of has followed me. I think every one of us has a personal vision, and sometimes we struggle with what that is, but I think if we can think about sort of our childhood dreams, those dreams that have endured throughout our lives, those I think are what drive us. Maybe I'm wrong, but for me, especially reflecting back on this autobiography, even in the work world, when I developed my vision, it was working, being successful as a team of equals. So I've always sort of focused on this idea of equality, but when I say equality, I just mean working together as peers.
Mm-hmm.
Working together as peers where everyone has a voice. And what drove me to education was, I had mentioned to you, I was actually thinking about what I was going to do in retirement, and I started teaching, and I loved it so much because, first of all, you're having a clear impact, you're contributing, and secondly, you're bringing happiness to people because they're able to get further in their careers, get to higher levels. You're maybe helping people see differently, and you're learning from them. I've learned so much from my students and my colleagues in the educational community, and I just feel like at this point, this is where I can make the biggest difference. So I think that's what really drives me here, and also the support that I get, for instance, to do something like this, and also to provide service. I just love providing service, and so I hope that's
that's wonderful.
An answer to your question.
Yeah, I think that's wonderful, and you essentially, basically, I think what I heard, you started, when you were a child, and you had this, you had this dream to do something, and I think it's really telling. I think everybody, it's really kind of like following your heart, like what you want to do,
Yes.
and also to have an impact. So that's all, kind of. I just want to share with you very quickly, because my own research is on urban transportation, air pollution, and public health.
Okay.
Because vehicles have emissions that then impact air quality and impact public health. So I've been thinking a lot of time. I was thinking, okay, why our cities are at this point, and what are going to be the future solutions? And I thought a lot about it, and in the end, my conclusion came back to education. So because I think kind of this urban infrastructure investment will change human behavior. However, this infrastructure decision making was made by humans. So how can we make our cities, not say as a host said, how can we make our cities more sustainable? It's not only about the hardware. There is also the social infrastructure, which are all based on human behavior. And I'm thinking how can best even change human behavior, and that draw me to education. So that's why I think education is really So,
I think what you're hitting sort of the nail on the head is, how do you bring a long-term view into the picture? If we have leaders in place that have a short-term view, then we get the outcome from that. We need leaders with a long-term view, and I think in systems engineering and in the systems world and in education, we take more of a long-term view. We're looking across the entire system life cycle. We're looking at all the impacts, not just how much does it cost to develop a system, but how much is it going to cost to maintain and operate it? How much is it going to cost when we eventually have to retire the system, if that's a system we want to retire? For world peace, of course, we don't want to retire that. We want that to be everlasting. So that system life cycle is going to go forever. But I think what you're hitting on is the ability to make an impact.
That's right.
But the long-term view, how do you bring the long-term view? And absolutely educating our leadership on the importance of the long-term view, and putting their decisions in the context of the system over the long term.
Yeah, I think both you and me, we firmly believe this. But of course, as systems, we always think beyond the boundary, right? So
yes.
So far, it seems like our conclusion is that education is really important, and both of us we would like to devote ourselves to the education, and especially this kind of life cycle view to look at things. And you say that we can educate our leaders to look at things, but then one thing comes up, right? For example, if you run a very successful either executive education or whatever education program, the program is so successful, and at the end of your program, all these leaders, they came up and they shake hands with you and say, "Oh, Alice, your work is great. Now I'm totally changed." Right? However, they are going to go back to their work. When they go back to their work, they will be evaluated by a lot of things that are not necessarily taking a life cycle view. So, right, and then 2 weeks after they left your class or your program, it will decay. So what I'm trying to say is that education, you can change a person's mind or something in your classroom. That's not too difficult. However, if we are not able to change, the big context environment, you can see that the power of education will still be limited. So how can we solve that problem?
Well, that's why I think we need to insert ourselves into solving these global challenges. So we, the educational community, the professional societies, the institutions that serve the community need to insert themselves into helping resolve these challenges. But also, we need to convince industry that they need a triple bottom line. Their bottom line will remain, one of the 3 prongs will remain profit, but it needs to also include impact to the environment and social community impact. So they need to be focused on 3 bottom lines in industry. And there's actually, I don't know if you've heard of it, the B Corporation, where there's a group of industries that are becoming certified as B corporations, where they have this triple bottom line. And so they need to be, industry needs to be working for good. And so we've got to keep working on that. It doesn't stop with the handshaking and the and the student going back to their work, we've got to continue to have influence past that point. And so in the B Corporation, they're actually legally required to assess impact on their customers, their community, their employees. And so these movements, Oliver, they're out there. These movements, we've got to support them. The educational community needs to support them, get involved, get educated, educate our students, continue the conversation past the completion of the degree, and the award, right, of the degree.
I see.
You have to continue. You can't, we can't let that happen.
I think that's definitely. I think that's a fabulous point, and I think actually, I guess you kind of re-emphasize. Actually, kind of probably, in a lot of time, people, at least you can see when I was talking about that, I was thinking about education just on campus, in classroom. But I think you made a very good point. It's really a lifelong learning for the student, and actually which is also kind of lifelong continuous. It's not only limited on campus, it's really educators. Mm-hmm. We need to reach out and closely engage all these different industry partners to continue and pushing these kind of views forward. I thank you for bringing that up. I think that's a very, very important point. Yeah, like actually if you think about education from that perspective, actually education on campus and university is just a tiny bit.
Right, exactly. It's just a stepping stone.
That's right.
In the larger system, which we always go to, right?
Yes. Yeah. I think this is wonderful. This is probably, I think, a very good time for us to close our conversation, and then we can, I can get you ready for your talk.
Great.
In the next room. This is great.
Thank you so much.
Thank you very much, Alice.